Hi everyone, my name is Jackie Chen, Solutions Marketing Manager in Max Data Storage. I've been working in Huawei for over 10 years, from R&D engineer to sales manager, most focusing on HPC storage solution. Today, I'm glad to share our thoughts on next generation storage decided for data-intensive HPC and how it could overcome the new challenges and shorten your research cycle. It is no secret that HPC is playing a critical role in our society. It has become an important driving force for social progress. For example, we can use HPC to accelerate drug screening, greatly shorten the R&D periods of new medicine. Another example is from genome sequencing. It took 13 years to complete the whole genome sequencing at the beginning. But with the help of HPC, we have shortened the time to just 1 day. In recent years, HPC has become even more closely integrated with big data and AI technology. Data is becoming more and more important. As we can see, the trend of HPC evolving from computing intensive to data intensive. Let's take a look at the HPC market growth rate on the right. It shows that data intensive HPC market, including HPDA and AI-based HPC, are growing much faster than traditional HPC market. And we found the workloads of data-intensive HPC has similar storage requirement. As we can see, industry get a lot of benefit from using HPDA and AI technology. However, this doesn't come without new challenges. There may be a lot of challenges to storage system. The top 3 challenges we think are as following. First, the new technology and application dramatically increase data volumes. Like texting cars generate 60 terabyte data per day for L4 autonomous driving. In oil exploration applications, upgrade from 2D to 3D, data generates 10 times than before. Most of the data are so important that they have to be stored over decades. Ever-growing data volumes will bring bigger challenges to HPC infrastructure, with uncertain situation on planning and expansion, such as no enough footprints in DC, more complex data lifecycle management, unpredictable scaling on capacity and performance for budget applying. The second challenge comes from supporting hybrid workload. For traditional applications, they often involve multiple processing phases. These phases usually have different I/O behaviors. I will take oil and gas explorations as an example. Seismic data processing requires high bandwidth, while seismic data interpretation needs high IOPS. Normally, 2 different storage systems are required to host these 2 types of workloads. Think about the supercomputing center. If different tenants have different workloads, how many systems are they going to set up? On the other hand, for emergent applications, they cause tremendous growth in diversified computing powers, such as GPU, NPU, and FPGA. This further increases the challenge of diversified workload support in same storage system. Third, the diversity of data access protocols makes multiple data copying, which hinders the efficiency of HPC. Let's take research on autonomous driving as an example. The development process involves multiple phases, such as data injection, data processing, model training, and simulation. There are diversified data access protocol interfaces. being used in those phases. For example, low texting data ingesting from S3 protocol, handling by bit data with HDFS, and result data for simulation or training by NFS. Meaning, you have to copy huge volume of data to multiple storage systems and waste a lot of time on waiting. But time is very important to the end-to-end development process. We heard a lot of complaints from our customer for this situation in different cases. So, what's the storage solution for overcoming these challenges in the trend of data-intensive HPC? The answer is our flagship distributed storage, OceanStor Pacific. Huawei OceanStor Pacific is a distributed scale-out storage system designed to support organizations' business and mission-critical HPC workloads across multiple protocols simultaneously. We believe these three features play a key role to shorten your research cycle. First, multiple protocol interworking tremendously reduce the copying across different analytical procedures, much improving efficiency. Next, hybrid workload-oriented design allows different workload applications running in the same system, reducing complexity of management. And high-density design release space in your data center. You know that in HPC, density is very important. Let's go through the key features with more detail. The architecture of OceanStor Pacific is aiming at data lake infrastructure for unstructured data. In design level, we create a new metadata system supporting both file and object, so that one copy of data could be read or written through different access protocols, such as NFS, SMB, HDFS, and S3. Besides reducing copying, higher analytical efficiency also comes from native protocol features support. When we talk about multiple protocol interworking, we really means there's no loss in both semantics and performance. You can see in the right table, comparing to other vendors, our solution has no gateway and could support native advanced features of different protocols, like object versioning and QoS at the same time. Next, as we know that management complexity comes from storage proliferation. High bandwidth and high IOPS in one system is always like a cake. You could not eat it and have it at the same time. Different workloads require multiple standalone storage systems, and proliferation starts. The OceanStor Pacific parallel file system is designed to optimize I/O metadata placement, keeping it close to the data on the nodes that own it. I/O processing and capacity management are likewise optimized using large I/O pass-through to bypass cache when appropriate, and a granularity specified layout that increases bandwidth for large block I/O stream while decreasing latency and I/O amplification for small block I/O. In this way, the system supports both bandwidth-intensive and IOPS-intensive workloads. Meanwhile, a lot of MPI I/O applications require high single-stream performance. As we know, the performance bottleneck is from NFS protocol. We put it as an option to install DPC for getting extreme high performance. DPC, or Distributed Parallel Client, is a private agency installing in hosts. In our lab, we have testing single-stream performance with DPC, comparing to other vendors' solution. We found the performance with our DPC reached 8 GB per second, 4 times higher than that running with NFS. Last but not the least, reducing high density matters in HPC, which will release space in your data center for the huge data volume growth. Our high-density hardware includes two models. First, high-density performance node, Ocean Store Pacific 9950. A 5-unit chassis houses 8 nodes with maximum 80 pieces of half-pump NVMe SSD disks, providing 160 GB per second on bandwidth and 200,000 IOPS. Second, high-density capacity node, Ocean Store Pacific 9550. A 5-unit chassis houses 120 pieces of 3.5 inches SATA disks, providing 1.68 petabyte raw capacity. On the right picture, as you could see, the high-density performance node has best density performance comparing to the other vendors, about 30% higher than the second best one. And the density capacity of the capacity node is 2.7 times than the general purpose high-density server solution. For continuously working in HPC, we will help different customers all over the world. Since time is limited, I will share a recent use case on HPDA. Sarikas, the research institute in Shanghai, China, built a HPDA platform with our distributed storage. As you could see in the left picture, one storage cluster supports both computing-intensive applications and data-intensive applications, with multiple protocol interworking and hybrid workload support. The analytical efficiency improved by 200%. To sum up, we think the next generation storage system will shorten research cycle by saving time, reducing complexity of management, and release space in your data center. For example, in meteorology research, with the help of multiple protocol interworking feature, one copy of data is read or written by data processing, data analysis, and product release, which is saving time in whole life cycle without waiting of multiple copying. In supercomputing center, hybrid workloads are supported in same system. As well as MPI I/O applications, one system can meet all the talent's demand, reducing complexity for storage proliferation. In scientific research, high density with both performance and capacity is always key to release space in your data center or server room, meaning you get rid of consolidation from other resources to get more footprint. At the end, I'd like to recommend you to read the ESG technical review for Ocean Store Pacific. After ESG strictly tested in the performance and features on Ocean Store Pacific, they recommended Ocean Store Pacific as the next generation storage system designed for HPDA. You could get the technical review paper by Google it with keyword ESG Ocean Store Pacific. That's all for my sharing. Thank you.